I'm Anil Kumar sharing with you few multiple choice questions based on a scenario which is an application of exponential function. So the scenario is, in a study of a new pain medication, it was found that 60% of a 320 milligram dose is still present in bloodstream after 30 minutes. So we have four parts to this particular question. Part A is, find the amount of medication in patient's body after T hours. Now we are given four choices. You have to select the right one. In the next set, you need to find the decay rate. Again, four choices are given to you. You can always pause the video, answer these questions, then look into my suggestions. And in part C, what we are trying to say here is that if the patient takes a dose of medication at noon, determine average rate of change of medication in the bloodstream from 2 p.m. to 3 p.m. So this is related to average rate of change. And the last part here is, if the patient takes a dose of medication at noon and is supposed to take more when initial dose reaches a level of 10% in the bloodstream, at what time should the patient take the next dose, right? So these are four parts for this question. You can always pause, answer these questions, and then look into my suggestions. So let's begin with part A. The question is, in a study of new pain medication, it was found that 60% of 320 milligram dose, so initial amount is 320 milligrams, 60% is present after time 30 minutes. So time is 30 minutes, which could be written as half an hour, right? And 60% remains. That also means that 40% decays. So think like this, okay? Now, based on this information, we can always write that the amount which remains will be initial amount of 320 times 60%. So 60% is 60 over 100, which is 0.60 to the power of T over half an hour, right? So over half. So which could be written as 320 times 0.60 2t, right? So that becomes the formula, which matches with option B. So that is the right answer for us, right? Now the second part of this question is, what is the decay rate for the medication in the bloodstream? Now the formula just derived was that at any instance of time, the amount which remains is 320 into 60% of 2t, right? Now 60%, this is the decay factor, right? So we want to find what is decay rate. So there are two terms. One is decay factor. Now factor is 60%. Now what is rate? That is what we have to find. So there is normally a confusion in this. So let me rewrite this. So when I say 0.60, I'm trying to say 1 minus 0.40, right, to the power of 2t. So every time it actually decays by 40%. 60% remains. So the decay rate is 40%, not 60%. So option B is the right option, correct? So you have to find this, which is called decay rate. So I hope this point is absolutely clear. Part C of the question is, in a study of a new pain medication, it was found that 60% of a 320 milligram dose is still present in the bloodstream after 30 minutes. If the patient takes a dose of medication at noon, determine average rate of change of medication in the bloodstream from 2 p.m. to 3 p.m. Now the formula, as we found, was that the medication concentration remaining was 320 times 0.60 to the power of 2t. Now we are starting at 12 noon, right? So after 2 hours, it will be 2 p.m. And after 3 hours, it will be 3 p.m. So the average rate of change is what? Is change in the medication level after 3 hours minus A of t 2 divided by 3 minus 2, right? So that becomes the average rate of change for that hour between 2 to 3 p.m., right? So for 3, we'll substitute 3 in t. So we get the equation 320 times 0.6 to the power of 2 times 3, which is 6, minus 320 0.6 to the power of 4 divided by 3 minus 2, right? So we could take 320 common, and we have here 0.6 to the power of 6 minus 0.6 to the power of 4, and this is 1. Units will be milligrams per hour. So let's use calculator and calculate this particular answer. So we have 320 within brackets 0.6 to the power of 6, take away 0.6 to the power of 4, which is equal to minus 26.5. Now minus indicates decay, right? So it is concentration is decreasing. The answer which matches is C, which is minus 27 milligrams per hour. So I hope these steps are absolutely clear. It's a very important part of this question. Now let's move on to the last part, which is in the same study. If a patient takes a dose of medication at noon and is supposed to take more when initial dose reaches a level of 10% in the bloodstream, at what time should the patient take the next dose? That means we started with 320 milligrams. We want to find what is 10% of this, which is 10 out of 100 of 320, right? Which is 32 milligrams. 32 milligrams. Now, we want to find the time when it reaches 32 milligrams. So the formula was E of t equals to 320, 0.6 to the power of 2t, right? So now the final amount is 32. So it is 32 equals to 320, 0.6 to the power of 2t. We need to find this time t now. So let's reorganize. So we have 32 over 320 equals to 0.6 to the power of 2t. Now that is equal to, you can say 1 over 10 or 0.1. Now at this stage, we can take logarithms both sides, correct? So we can do log of 0.1 equals to, when you take log, you get it 2t log of 0.6, correct? So we can now isolate t and find the time. So 2t is equal to log of 0.1 divided by log of 0.6. So let's use calculator, find this time. So it is log of 0.1 divided by log of 0.6. It gives us 4.507. So t is 4.507 divided by 2. So we'll divide this by 2. We get 2.25. So time is in hours, 2.25 hours, right? Now that means 2 hours, and 0.25 means quarter, right? So quarter of an hour is 15 minutes. Which matches is 2:15 p.m. Some of you could also do like this. 0.25, you could do like this. 0.25 times 60, right? To convert that to minutes. So you get here 15 minutes. Perfect. So, and then the option is B, which is 2:15. So I hope the steps are absolutely clear. Feel free to write your comments and share your views. If you really like and subscribe to my videos, that'd be great. Thanks for watching and all the best.